Okay. So let's talk about one-to-one. What does it mean for a function to be one-to-one? So one-to-one simply means that you don't have any repeats. So there are no repeats. In X or Y. So you can't have any repeats. That's what it means to be one-to-one. I feel like we talked about this before on a different quiz or topic, but so we're just going to revisit it. So when I look at this first set of ordered pairs, so questions A through B are ordered pairs. I'm going to look at my X values. So 2, 3, -3, and 7. Are any of those numbers the same? Do we have any repeating numbers that I just underlined? No. All right, so now let's check our Y values. 5, 7, 6, 4. Are any of those numbers the same? There's notes in the front by the computer. Are any of those numbers the same? All right, so all of our numbers are different. We don't have any repeats, so this is one-to-one, so I would say yes. Let's look at question B. Do you see any repeats in X or Y? All right, I agree. What do you see that's repeating? 8. 8 for the Y's. So I have two Y values that have an 8. So this would be a no. This is not one-to-one. All right, let's look at question C. Are there any repeats? What is repeating? 4. We have two X values that have a 4. So that is a no. And what about D? What's repeating? 2 in the Y. Good job. Okay, so the beginning of homework, 19, is just looking at relations and maps and graphs and telling me if it's one-to-one. Just a yes or no question. All right, so let's look at these 4. These are what we call maps. Okay, and in a map, you put all of your X values in the first oval, all of your Y values in the second oval, and you draw a line to the coordinate. So for example, this one, if I were to write this as ordered pairs, all right, I would have a point at AD, and this next point would be BE, and then I would have CE. That's how you would write it as ordered pairs. And notice how we have a repeat. And what's repeating? E. Okay. Looking at a map is easy to tell because you'll have two lines connected to a single point. So I have two different lines going to E, and that's how I know that E is repeating. So you don't necessarily need to write them as a set of ordered pairs. So this is also going to be a no. This is not one-to-one. All right, when I look at F, let's look at this one here. I can tell immediately that A is repeating because I have two lines coming off that point A. So there's a point for AD and another point for AE. So A is repeating, so that's a no. So E is no, F is no. What about G? G is a yes. All right, I have 3 points. My first point is AR. My second point is CQ. And my last point is DS. I don't have any repeats. So G is yes. And what about H? H is a no. We have several things that are repeating. A is repeating, B is repeating, P and Q are all repeating, and R. Okay, so there's a lot of repeats. Okay, what if it is a graph? So how do we know if it's one-to-one if it's a graph? When we're looking at a graph, it has to pass. Does anybody remember? vertical line and horizontal. So the vertical line test will tell us if it's a function. But for it to be one-to-one, it has to pass a horizontal and a vertical line test. Which means that when I draw my line, it can only cross one time. So that's how you know looking at a graph. So this first one, if I draw a horizontal line, notice that that horizontal line crosses through the parabola twice. So because it passes through twice, this is a no. That's not one-to-one. Parabolas have repeating y values. K is actually a log, which is what is going to be in your Chapter 5 test, not the Chapter 5 quiz. We'll talk about that the end of next week. If I draw a horizontal line, it only crosses the graph one time. And if I draw a vertical line, it only crosses one time. So this is a yes. Now, if you zoom into this graph, it may look like it's not, like it may look like it's going straight down, but it's really not. It's just decreasing very slowly because there's a vertical asymptote for a log, and we'll talk about that later. But for a logarithm, it is a yes. There are no repeating y or x values. And then our graph L is also one-to-one. If I draw a horizontal line, it crosses the graph only one time. There is a horizontal asymptote, as we all know, because we just did our test over it. But it does not cross through. If I draw a horizontal line, it's not going to cross it more than once. And if I draw a vertical line, it doesn't cross it more than once. So this is also a yes. So at the beginning of the homework 19, the first 4 or 5 questions is just a yes or no question. No math involved. Is it one-to-one? Yes or no? All right, so now let's revisit what we talked about yesterday on finding. We're going to find the inverse and verify that they're inverses. And we did this yesterday. So remember, to verify that it's an inverse, we need to do a composition. So let's start off by finding f of g. So we're going to take this g function and put it right here. So what I like to do is write the function that I'm putting, the holder function, which in this case is f of x. I'm going to write it with parentheses. So it would be 3 parentheses minus 9. So instead of x, we're putting parentheses there. Go ahead and drop that function into the parentheses. So distribute the 3. So you're taking 3 times 1/3 and 3 times 3. So 3 times 1/3 is just, what is 3 times 1/3? 1, yep. So you have 1x, and then 3 times 3 is 9. Bring down that minus 9 that's on the outside. And when we combine our like terms, a positive 9 and a negative 9 cancel out. So I'm left with an x. So because I have an x, I know that f of x and g of x are inverses. My hand was not writing as fast as my mouth. I was saying f of x and g of x are inverses. And when you do your test, you don't have to do both. You can do g of f or you can do f of g. But either way, you have to show me that it is going to equal x. All right, let's look at example 3. In example 3, Again, we're going to figure out if they're inverses. So I'm going to find f of g. So let's take this. And before I move it, I'm just going to rewrite this function, and I'm putting parentheses where there's an x. So I'm literally just rewriting it and putting an x where I have highlighted in yellow. So I have parentheses, and then I have a second set of parentheses, plus 3 squared. So I rewrote the f function and put parentheses where my x was. And now inside of the parentheses, let's go ahead and drop in our g function. Okay, so there is nothing in front of this blue parentheses. There's nothing I need to distribute inside, so I can actually just get rid of my blue parentheses now. So I'm going to rewrite this function and eliminate that parentheses. So I just have parentheses root x minus 3 plus 3 squared. Yes.
Why couldn't you just put the 4 in there?
4?
Yeah.
Where do you see 4?
Remember yesterday?
Oh, there's no numbers. There is no number for us to put in here. If there was a number, it would be in here.
Oh.
Yeah. Where did you get the 4? The number 4?
Remember yesterday when you did the 2 sets of parentheses?
Oh, okay. It was, yeah, because it was a number. Okay. If you look at F of your 5.1 notes, there were numbers inside. And this is different because this is verifying. Okay, so these 3's are not underneath the square root, so we can combine these together. And what do you get when you subtract 3 and then add 3? You get 0. So I'm left with just a square root of x that is squared. And if you square root something that is squared, what's going to happen? It cancels out. So I'm left with just an x. So again, f of x and g of x are inverses. So now we're going to practice finding the inverse. So for this first one, we're going to find the inverse and graph it. So when you find the inverse, the way we show that it's an inverse is by putting the -1 next to the f. And let me go ahead and take off these graphs. I may not be able to. They may have to stay. All right, so let's go ahead and find our inverse. So to find my inverse, step number 1 is I always write it with a y instead of an f of x. So you have y equals 2x plus 4. Anybody, well, this is going way back to algebra 2, but anybody remember how you find inverses? All right, so we're going to switch x and y. So x equals 2y plus 4. And now solve that equation for y. So how would I solve that second equation for y? What would I do first with that plus 4? So we need to get this y by itself. So we're going to start by subtracting 4. So that would be x minus 4 equals 2y. And now we're dividing everything by 2. So there's an invisible 1 right here in front of the x. So I'm left with 1/2 x, because 1 divided by 2 is 1/2. And then 4 divided by 2 is 2. And that is my inverse. And I'm going to show that that's the inverse by putting the -1 there. This just simply means that this is the inverse of f of x. And that's how you want to notate it. All right, so now you're ready to graph it. So we're going to graph both. My graphs are still up there from first period. So now you're going to graph them both. So let's go ahead and start with the inverse since we have it. My inverse has a slope of 1/2 and a y-intercept at -2. So if you look at the screen, you can see how I graph that. You're going to start at -2, put a point at -2. That's your y-intercept, and then your slope is 1/2. So you move up 1, to the right 2, up 1, to the right 2. Go ahead and draw your line. Okay, so then my red line is my inverse, so I'm going to label that as inverse of function f. And now let's go ahead and also graph the original function, which is here, what we started off with. So our original function had a slope of 2/1 and a y-intercept of +4. So graph that also. Put a point at 4 on the y-axis. And you can see I already graphed it, but I started here at the 4. And then you go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. So there are two different functions that we graphed. We graphed f of x, and we also graphed the inverse. So for our last three functions, we have a lot more algebra. So we're going to solve some equations. We don't have to graph the last three though. We just have to find the inverse and put it in inverse notation. Okay, let's go ahead and do our last three. All right, so now we have to find the inverse, okay? So the first thing we're going to do, step number 1, is write it with a y. So y equals 2 divided by x plus 3. Step number 2 is switch your x and y. So that becomes x equals 2 divided by y plus 3. So we need to solve this for y. And this one is a little trickier. So I'm going to put this over 1. So let's cross multiply. So we're going to multiply this direction, and we're going to multiply this direction. So I have x times y plus 3 equals 2 times 1. And then I'm trying to solve it for y. So the easiest way to do this, though, is not to distribute the x. It's to just get rid of the x. So how could I just get rid of the x? Divide it. Let's divide both sides by x. So when I divide both sides by x, I have y plus 3 equals 2 divided by x. And then my last step is to get rid of the plus 3. And how do I get rid of the plus 3? Subtract it. So my inverse function would be inverse of f is 2 divided by x, and then the minus 3 is off to the side. And this would be my final inverse function. So I'm subtracting the 3 from 2 divided by x. Okay, let's do our next one. So for our next one again, so this one gets a little bit more complicated because we have x in 2 different spots, which means we'll have y in 2 different spots. So I have y equals 5x divided by x minus 1. So x equals 5y divided by y minus 1. So now I have y in 2 different spots. So we're going to start off by cross multiplying. So I'm going to take x times x minus 1 and then 5y times 1. So I'll have x times y minus 1 equals 5y. So this one is a little different from the last one only because we have y in 2 places. So we can't go about it the same way. Instead of dividing both sides by x, we have to distribute the x. So when you see y in more than one spot, we have to distribute the x. So let's go ahead and distribute x. And that's going to give you xy minus x equals 5y. So what we need to do is bring all the terms that have a y together. So these two, because I have y in 2 different places, they need to come together on the same side. And then the terms that don't have a y can be on the different side. So what we need to do is I need to move this yellow term over so it can be with the other term with the y. So the way I'm going to do that, because this term is positive, is subtract it. So that's going to give me negative x equals 5y minus xy. So they're not like terms. We can't bring them together, but we can bring them on the same side. So now what we can do is take out that y. So we're going to take out the GCF of y. And when I take out my greatest common factor of y, what do I have left inside of my parentheses? 5 minus x. So now we only have y in one spot. So what do you think I'm going to do? Because I need to get rid of this, which is being multiplied by y. How do I get rid of this group? If it's being multiplied, I'm going to divide it. So we're going to divide both sides by 5 minus x. So my inverse function is right here. because when I do that, this side, this is going to go away. So all I'll have is a y. So my inverse function would be negative x over 5 minus x equals my inverse function of f. So that one is just a little bit more algebra. It's kind of going back to how good are you at solving an equation. So that's the main thing that kind of makes it tricky. All right, our last one, let's go ahead and do it. So I have y equals 2x minus 1 over x plus 4. X equals 2y minus 1 over y plus 4. So we're going to do it the exact same way we did example 6. So we start off by cross multiplying. So I have y plus 4 times x. So x times y plus 4 equals 2y minus 1. So I cross multiply x times y plus 4 equals 1 times 2y minus 1. Go ahead and distribute the x. So because we have y in 2 different places, we have to distribute. So I need to bring everything with a y. I'm going to bring everything with a y to the left. And everything that doesn't have a y is going to go to the right. So we got to move some stuff around. So I need to move my yellow terms to one side and my blue terms to another side. So let's start off by moving our yellow terms. So let's subtract that 2y. So that'll give me xy minus 2y plus 4x equals negative 1. And now I still have to move my blue terms together. So this term, these two terms have to be together. So how do I move that 4x over? 4x is positive, so I'm going to subtract it. Let's do that. So that gives me xy minus 2y equals negative 1 minus 4x. So now what do you think I'm going to do? Because I need to take these out so it's in one spot. See, I have y in 2 different places. So let's take out our GCF, which is a y. And when I take out that y, what will be inside of my parentheses? X minus 2. Good job. So your last step is to divide both sides by x minus 2. And you are finished. Because that cancels out. So now y is by itself. So my inverse function is negative 1 minus 4x over x minus 2.